intelligence. Is it spooky? Is it scary? Will it take over the world? Nope. Artificial intelligence is really just a bunch of math. That's it. Just math. Bunch of numbers, calculations, stuff. Do it on the computer. Anyways, so artificial intelligence has been defined as the ability for a machine to do something without explicitly being programmed. So why would you want a machine to do something without it explicitly being programmed to do so? Well, there are lots of tasks that the explicit programming, the number of instructions a human would actually have to sit down and write to execute the program is way too infeasible. It would take millions and millions of lines of code, complicated logic, and it would be almost impossible to bring anything out of the data set, which is so large, in order to make a meaningful program from it. So we need the machines to be able to learn from the data and figure out useful information from it. So, ability to execute a task without explicitly being programmed. So it's also made up of two main steps, training and inference. And the training step is basically where the machine is trying to learn something about the data, and the inference step is where it's given new data and you want it to produce something useful from that new data. So the training step, where it's actually trying to learn something, what is that? Well, it's really trying to fit data. So what does that mean? Just like with a t-shirt or a pair of pants, you want it to fit well. You want it to be the right size, the right length, and all of the right dimensions. So when the machine is trying to fit the data, it's trying to find the right dimensions of the data that produce something meaningful and give an accurate fit, such that when it sees a new data point, it can fit that data point as well into its understanding of the information. So just like when you have a well-fitting pair of pants and you know your size, you can get any pair of pants from then on that are the same size, and you know that they'll fit because they match your dimensions. Theoretically, you could also make a pair of pants that has those same dimensions, and they would also fit you, theoretically. So that's what the fitting process is sort of analogous to. And during that fitting process, it's trying to minimize a cost. So we'll get into that later. So once it has fit the data, let's say we have a bunch of images, and it has learned that the images have certain classes of things in them. So the images you've given it, say they have dogs, cats, cars, streetlights, other people, things like that, and you want it to be able to take in a new image and output the class of the items in that image. So that's what the inference step does. So why is it useful? Why do we have machine learning and an artificial intelligence in the first place? Well, it can do tons of amazing things, and like I said before, writing the programs to do these things would be intractable and infeasible because it would take millions of lines of code, and it would take probably thousands of people, or at least thousands of hours to be able to write this kind of complex program. So you can imagine with an image, let's say there's 2 million pixels in the image. That's 2 million times 3 for RGB for each pixel, 6 million data points. So imagine being handed a list of 6 million numbers and trying to produce what is in that list of 6 million numbers. It would be ridiculous to try and do that. So that's part of the reason why we need machine learning and artificial intelligence. So one of the things that it's really good at is classifying. So just like we said with images, it can tell you what's in the image. Also given text, it can tell you maybe certain attributes about the text, like is it a negative sentence or paragraph, or is it positive? Also, it can tell you things like what's the category of the text, if it's constrained to some domain, and also it can do things like speech classification. So given a audio input file, it could output the words that are in that file. Another thing that it's good at is prediction. So let's say you have old stock market data of years and years past, and you want to train a machine to learn from that data and learn useful dimensions and attributes about it. So you can take all of that data, train the machine on it, and then given new stock market data, try to predict something meaningful out of it. Like, should I make a trade or not? Will this be risky or not? How much risk? What are the dimensions of something useful that you would want to output from the new data that it has never seen before? So another thing that machine learning is also really amazing at is clustering. So with clustering, we might have a bunch of users or any kind of other data point, like let's say house prices and the attributes about the house, like how many rooms, what's the square footage, what are the number of bathrooms, things like that. And let's say we have this data, but we don't know if there's any structure or meaning to it. We don't know if there are buckets we can classify different sets of the data into. So maybe the users, there are users who are very conservative with their buying, or maybe there are users who really like athletic wear, and these could be seen in the data if you were able excuse me, to visualize it, but sometimes the number of dimensions is so high you can't meaningfully look at the data on a plot or a three-dimensional or even two-dimensional plot and see anything from it. So we need the machine to tell us, like with the t-shirt example, it's going to try to fit the clusters as best it can and find the dividing lines between those datas in the higher dimensional space. And so once it does that, if you have a low enough score for the clusters, meaning they are a good fit for the data, then that means that you probably have some meaningful buckets or classes that you can pull out of the data and actually use later on. So if it's users, maybe you've got these clusters of users that are characteristic of different behaviors. So some users really like to buy online, some users like to add to cart, or maybe they purchase it and go pick it up in the store, something like that. Then given a new user coming in, you could say, given partial information, maybe they haven't bought anything yet, based on their activity at that point, what you can try to predict based on the previous known clusters, what behavior they're going to be most similar to with like the other clusters. So the last one that I really like is also anomaly detection. So this is one of the amazing things also about machine learning that's just unbelievable in some ways. So for instance, there is a group of students, I think at Stanford, who were working with a nuclear reactor, and they were trying to take data which was coming out of the reactor, so things like sensor data, like temperatures, maybe voltages, all kinds of things like that that's useful to know, and then trying to predict, will there be a malfunction in the nuclear reactor, which is unbelievable. It's crazy to think that you can take the data coming out of something and train a machine on old data where the reactors have gone bad before, and given some new data, have it tell you if an anomaly is happening, if this behavior that's being exhibited is actually strange, and should you do something about it. Say galaxies. If you're looking at images of galaxies, there are so many images of them in the sky from telescopes that we could never look through all of them as humans. Well, if we want to train our machine to look at galaxies, we could identify a few examples of galaxies that are strange that we already know about, and then say, hey, look for these type of attributes in the new data and tell me if there's an anomaly. So it sees thousands of galaxies and says, okay, these are all the same, that one's the same, I've already seen that. Oh, wait a second, this one's really crazy, so I'm going to send off an alert and say, hey, maybe you should check this one out. The next thing that I want to talk about is, how does this all work? So a good analogy for the actual training process of machine learning, so it's like, how do we train it to do something? There's two different ways we can train it to do something. We can give it a large data set that's already been labeled by humans. So essentially we're telling it, hey, replicate what these people have done, and when I give you new examples, hopefully you have learned that well enough to apply it to new examples. The other case is unsupervised data, which is like the clustering and the anomaly detection, where you don't know what the structure is beforehand of the data, but you want the machine to figure out if there's any structure to it. So the way this actually works, and a good real-world analogy that I like is baking a cake. So if you imagine having a recipe, right? There's inputs to the recipe and there's an output to the recipe. So if you're baking a cake, there's all of the ingredients and the output is a single cake. And so the intermediate steps there are your recipe. And just like with machine learning, the intermediate steps are what the machine is doing with the input data to output some kind of meaningful result. With your recipe, you have all these steps that you follow. So you combine the ingredients in different ways, and you might combine several ingredients, let's say the dry ingredients, then you combine the wet ingredients, then you combine both of those together, and then you finally bake it. And so you can say, all right, well, if I bake this cake and I get something out of it, if you're dealing with supervised learning, you could say, I baked this cake and it looks like mush, so it's definitely not what we want. And the supervised learning example would say, here's what the cake should actually look like, because a human has said explicitly that this is what a good cake is. And so you can tell the machine, or yourself baking the cake could say, I know that this blob of batter is very different from this cake that I am trying to get to. So maybe you try to say, okay, I'll tune up my baking time a little bit, and hopefully that gets me closer to the desired cake that I want. So you literally repeat the whole process again, changing nothing except the baking time. And then if you get a little bit closer to the desired cake, that means your cost is lowered. So you're trying to minimize this cost of how wrong you are on your guess or your attempt at producing something useful. And so you can compare what you've produced to the label or human modeled example and say how different they are. And based on how different they are, you're going to go back and change your process and tweak it a little bit to try to ultimately get closer to the desired result. So maybe it wasn't sweet enough, so then you repeat the process and you add a little bit more sugar the next time. And that's the only thing that you change. Or maybe you change several things, but that kind of makes it harder because you don't know which step led to what. And so this iterative process of updating your recipe and the steps in your recipe actually is what the machine is doing when it learns about data. So it's trying to replicate a known answer by taking input and producing an output, comparing how close that output is to the known or labeled set, and then going back, tweaking its process a little bit and trying again. So that's literally what supervised learning does when it's trying to fit the data. It's trying to find the useful dimensions of the data. And with unsupervised, you still have a cost associated, but you don't have any labels. And so you're ultimately just trying to minimize some distance value. Okay, so that's pretty much how and why and what machine learning is. So why do you care? Why does machine learning apply to anybody on a day-to-day basis? You know, it's not just some crazy abstract concept that is only practiced by high priests in high lands who know ridiculous mathematics. So that's definitely not true. It's used every day, probably in everything that you do. If you have ever bought something online and seen a recommendation, that's machine learning. You're being compared to other users based on your behavior, and they're predicting what you might want to buy next. Another thing that it's used in is, say, Netflix for title recommendations, or Spotify for playlist recommendations and things like that. So another really common practice of this is voice recognition. So if you've ever used a voice assistant like Siri or Google Home or Alexa, anything like that, taking that text or taking the speech and turning it into text, that is literally based on a machine learning process where it's been trained to take in audio data and produce actual text from it. Okay, so last one I want to talk about is self-driving cars. So obviously self-driving cars are on the horizon. They're super cool, super hot topic, and they pretty much rely solely or mostly on machine learning for their eyes. So when the cars take in data from their cameras, they have to tell what's in the images that they're seeing. Is it a pedestrian or a car? Obviously, that classification is extremely important to know, because if it's a car, maybe it's okay that you can't stop. If it's a human, you better get out of the way. So that distinction is huge. And so the machine learning and artificial intelligent models that people have created to take in image data and output classifications and bounding boxes are what really is one of the biggest drivers of giving the cars the ability to actually have some understanding of the environment that they're in and be able to navigate through it usefully. Just like with the humans in the cars example, you can also say, okay, I'm going to classify, maybe if I see two lines going like this, that means it's a road and I need to keep going straight. And if you see two lines going like this, that's classified as a turn, and so I actually need to turn the wheels of the car to go that way. So that is how it really applies in everyday life. There's tons more examples, and if you want to know more, I'll post some links as well, but there is an infinite wealth of knowledge online about this stuff. I learned myself personally about all of this online, on my own. Didn't take any classes, didn't spend any money, nothing like that. So I'm going to leave you with that, and thank you very much. Is it spooky? Is it scary? Will it take over the world?